Hey everybody! Today we're going to be dividing using a bar model. This is a newer method of dividing. It will still get you the same answer, but it is a new way showing partial quotients and a bar model which our students are familiar using because of multiplication. So let's take a division problem such as 428 divided by 7. So the first thing that you're going to do when dividing using an area model is you're going to take your dividend, which is the number that is being divided, and your divisor, which is the number that is doing the dividing. You're going to put those on your area model. The divisor goes outside the box to the left, and your dividend goes inside the box towards the top. So we all know that 7 can go into 428 at least once. So one group of 7 is equal to 7. If I take that away, I am left with 421. Then I can go ahead and subtract again. I take what's left of my dividend and bring it up to the top of my next box. So now my dividend is 421. I know that one group of 7 fits in to 421. When I subtract, 11 minus 7 is 4, 1 minus nothing is 1, 4 minus nothing is 4. And I keep going, subtracting one group of 7 until I get to 0 or a number that is less than 7. That would take an awful long time. Because we know that division is repeated subtraction, this is the first area that we show students so they can understand the concept of division as repeated subtraction. But we don't want it to take that long. We know that if one group fits, and 428 is a pretty big number, maybe 2 groups would fit, or 3 groups would fit. But what we have started doing is, if I start with a new area model, my divisor on the outside, my dividend in the box, maybe 10 groups of 7 would fit. 10 groups of 7 is equal to 70. 428 minus 70, 8 minus 0 is 8. 2 minus 7 is impossible, so I need to borrow. 12 minus 7 is 5. 3 minus nothing is 3. Now, as you can see, instead of taking away just a small group of 7, I'm taking away a bigger group of 70. And I can continue doing this, taking 10 groups of 7. Remember, my new dividend goes in my next box. 10 groups of 7 is 70. I need to remember to regroup. And like I said, you can continue doing this until you get your dividend to 0 or a number less than 7. So if I were to continue doing 10 groups of 7 is 70. I subtract, continue moving the dividend up to the top. I could do that. As you can see, instead of just taking 7 away each time, I'm taking 70 away each time. This still takes just a little bit longer and it takes a lot more steps. For some students, it's going to be helpful to do baby steps at a time until they're comfortable figuring out maybe not just 1 10, maybe 4 10s or 5 10s would fit into 428. I'm going to show you how to do that next. So if we take 428 divided by 7, I always recommend starting with just one box. You never know how many you might need. My divisor's on the outside. My dividend is inside the box. Now what you should ask your student is, we know that one group of 7 would fit. We know that 10 groups of 7 would fit. But what about multiples of 10? Would 20 groups of 7 fit into 428? Yes, it would, because we know that 20 groups of 7, or 20 times 7, is 140. What about 30 groups of 7? That would fit because that's 210. How about 40 groups of 7? 50 groups of 7? And what you're going to do is you're going to keep multiplying until you are as close as you can get without going over, or you go over. So, for the sake of time, I know that 60 times 7 is 420. If you were to keep going, you would get to 70 times 7, 490. That's too much. So, 60 groups of 7 is as close as I can get without going over 428. And just like in this, I put my 10, and I had 10 groups of 7 was 70. 60. So 60 groups of 7 is 420. Now I can subtract again. I take my dividend, take away the groups. 428 minus 420 is 8. I take my new dividend up to the top, and we all know that only one group of 7 will go into 8. 1 times 7 is 7. 8 minus 7 is 1. 1 is my remainder. I'm not quite finished yet, because what I need to do is I need to take this 60 and 1 and add them together. 60 plus 1 is 61, remainder 1. You might be asking how this relates to the traditional vertical division that you may have learned in school. 428 divided by 7. You may have remembered, okay, does 7 go into 4? Nope. Does 7 go into 42? Yes, it does. It goes into 42 6 times. We subtract 42 and we get 0. But in reality, we're not just subtracting 42. We're subtracting 42 tens because the 6 is in the tens place. 61, the 6 is in the tens place. Then we bring down our 8, and we say 7 can go into 8 one time. One group of 7 is 7. You subtract and get your remainder of 1, which you bring back up to the top. The purpose of students doing the bar model this way is to help them understand place value of numbers. Yes, 61 remainder 1 is the same answer as this. This is a few less steps. It's a little bit less confusing for those of us who have learned it this way. But at the same time, you never really realize that the 428, you're really saying 6 tens go into 420. Or 6 tens, and 7 groups of those 6 tens go into 428, 42. Bring down your 8. Let me show you one last thing. So let's say we're going to use the 428 divided by 7 again. For some reason, the 7s are a little bit trickier for some kids. So maybe in creating your area model, divisor on the outside, dividend on the inside. Yes, we know that one group of 7 will go into 428. Yes, 10 groups of 7 will go into 428. And maybe your student is only comfortable going up to their 5s. 5s are easy, you can count. 5, 10, 15, 20, 25, and so on. So let's say that your student knows, oh yeah, I know that 5 times 7 is 35. So 50 times 7 is 350. Let's start there. It's a bigger number than 7, if I would just do one group of 7. It's also a little bit closer. It's not maybe quite there, but let's try that one. So your student might want to say, okay, let's do 50. 50 groups of 7 is 350. I'm going to subtract. 8 minus 0 is 8. I need to regroup. Now I'm left with a smaller number. But your student knows, because they've been practicing, that as soon as we bring our new dividend up top, okay, well, if I only take away one group of 7, and I do 78 minus 7, that's still going to take a while. So what if I do 5 groups of 7? Because I already know that 5 groups of 7 is 35. Subtract, they get 43. Well, 43 is still less than 35. So 5 groups of 7 again, my new dividend, 5 groups of 7, subtract, we need to regroup. 13 minus 5 is 8. Now they know 8 is still more than 7, so I can get one more group of 7, and I'll have 1 left over. Now what I do, just like I did on my original problem, 50 plus 5 plus 5 plus 1 is 61 with a remainder of 1. There are countless ways for students to go through and figure out the answer to the problem. The benefit to doing multiples of 10 is that you only have to take 2 steps. For students who are not as comfortable using their multiplication facts, or students who are still learning them, it might be nice for them to use facts that they are comfortable with, like their 5 times facts. And if we had continued going, students would have gotten to the correct answer by using tens. 10 times 7 is 70, and eventually we would have gotten the correct answer. It would have just taken a little bit more perseverance and a little bit more stamina. I really recommend students using facts that they're comfortable with, such as 5s, 4s, and 3s. And another good strategy, which I used before, is writing out 20 times 7, 30 times 7, 40 times 7. The same would go if you're using a number in the thousands place, which the students will be doing very soon. 3,248 divided by 2. We know that 3,248, 2 can go into it at least once. 1 times 2 is 2, subtract 2, repeated subtraction. It would take a very long time. 2 times 1 is 2. How about 2 times 10? 2 times 10 is 20. That would still take a very, very long time. So I'm going to go to 2 times 100. 2 times 100 is 200. That still might take a while, not quite as long, but it would take many steps. So let's even go up to 2 times 1,000. That would be 2,000. Just to check, 2 times 10,000, which your students should immediately know, is too much. So we're not going to go all the way up there. If it were a different number in my thousands place, I would then ask students, okay, 2 times 1,000, what about 2 times 2,000? 2 times 3,000. You might even want to have your student check 2 times 2,000 just to be sure. It's too much. So when we subtract, we're going to say that 1,000 groups of 2 goes into 3,248. I subtract, I get 1,248. The next step would be, all right, well, 1,000, 2 times 1,000 is too much. So we're not going to use that anymore. 2 times 100, well, that's not quite enough. So let's start writing out our 2 times hundreds facts. 2 times 200, 2 times 300. Eventually, your student will get comfortable enough, realize The 12 is what they're trying to get close to.